Hi folks, this video is going to be on atmospheric depressions. These are very important to know for extreme weather and for hydrometeorological hazards as part of the Natural Hazards course. So they're very important. And we get a lot of them in the UK. So if we're thinking about atmospheric conditions that you can see yourself, they are very easy to see and very common. So we're going to think about three things. We're going to think about 1, what is a depression? 2, how does it form? And 3, what conditions do we see if there's a depression? Now, depression is an area of low pressure air which is moving upwards. If you're thinking about pressure, you need to think about what pressure is. So pressure is when something's being pressed down upon you or pressed into something. That is pressure. Pressure, press. Makes sense, doesn't it? So low pressure air, there's not much that's pressing down on that air. In fact, there's nothing pressing down on that air, so it can just lift up. It's a gas, it'll lift up. And that's what happens. We have a low pressure area and the air lifts up. And as we can see, it also rises up in an anti-clockwise fashion. So it spins as it rises up. This is due to the spinning of the Earth and the spinning of the air movements themselves. And quite conveniently, completely by coincidence as far as I'm aware, it's also the same as a screw thread. So if you've ever done woodwork, you might have heard the term lefty-loosey. And that is, if you turn your screwdriver, and you've got a screw, if you turn it to the left or anti-clockwise, you actually find that the screw lifts up out of whatever it's in. And it's the same for air. Air that's going down spins clockwise, air that's going up spins anti-clockwise. So it's worth knowing that. Now it's spinning and it's rising, this low pressure air. I say that is because of the spinning of the Earth, but this then has effects on our air systems and on how these depressions form. If we have a look to my diagram of the UK here, this is in the northern hemisphere, we have cold air and warm air meeting each other at what's called the polar front. It's called front because it's the front side of both air masses coming together. Cold polar air moves one way, warm tropical air moves the other way. Warm tropical to the east, cold polar to the west. Now this polar front wiggles around quite a lot. It's quite unstable. It keeps shifting around, and that is essentially the guide for all the weather that we get. Now cold polar air and warm tropical air are kind of like oil and water. They don't really want to mix together. So if they do come into contact with each other, they won't mesh. They'll instead try to work around each other. And that's how depression begins. It's when this cold air and this warm air end up colliding with each other, and it sort of sets almost like a whirlpool effect into motion. So what we get here is a bit of warm air ends up jutting into the cold air, and the cold air starts to sort of jut back in as well. And they don't want to mix, so the cold air catches against the warm air, warm against the cold, and they start to spin around. And that creates the start of a depression. We've got the warm air, which is poking its way in and creates what's called a warm front. So this area here is called the warm front. Front is anywhere where two air masses are meeting. This bit behind is called the cold front because it's the front of the cold air. So the cold air is pushing in, it's the front of that there. That's the front of the warm air which is pushing its way in there. And this is how depression starts. Now if we're looking at sort of ground level view, in the upper atmosphere up here and then down at the ground level, we've got these two masses of air to move moving in together, like this. Now the warm air, because warm things rise, wants to get above the cold air. So this warm front is actually at an angle, going up and over the cold air. And then you've got cold air, which is coming in underneath and pushing its way behind like a wedge. So the whole thing is moving in kind of that shape, moving around, and because it's being pushed up, it goes upwards and anti-clockwise. Hence why we get this anti-clockwise spin. So that's sort of wedge shape, and it's working its way upwards. And that's the formation of the embryo depression, as we call it. It then moves on to its next stage, a mature depression. And the mature depression is where this is developing weather systems, and it's creating a much bigger atmospheric impact. We've now moved on to our mature depression stage. And what's happening here is that the warm air has cut even further into the polar air, and the polar air is coming in behind that warm air because it wants to seal that gap. It wants to close it up. It doesn't want that warm air to be there. And it's spinning around this area here. It's hinging on this point here. This point is our point of real low pressure. And it's like a pivot, making its way around. And down at ground level, it looks sort of like this. You've got the cold air here and here, and the warm air is pushing up and over the cold air. And then we've got the cold air coming in behind this bit here, trying to close the gap, and it's coming in underneath and undercutting that warm air. So that's what's creating that upward cycle again, remember. That's that undercutting, it's being pushed up. It's got these sloped edges on, so it's spinning around, it's lifting up, and it's moving along. And you'll see on maps, what we call the synoptic charts for the weather, you'll see these symbols. Now unfortunately I don't have a red, so you just have to bear with me on this. But on a warm front you will see red semicircles, and on a cold front blue triangles. So that's how you know where the fronts are. The thing is, cold air moves faster than warm air. It's just one of those facts. Cold moves quick. So what happens eventually is that cold air is going to catch up and meet up with that warm air. That's going to lead to the final stage of the depression. In our final stage, at the end of the depression, what's happening is the cold air has caught up with the warm air. They've closed the gap. And they've sort of closed the gap and started to scoop that warm air out the top. As soon as the cold and the warm air come together, the depression loses its power, loses what's driving it, and it just disappears. Once that bit closes up with that gap, it'll be back to how it started again, and it can all begin again. Cold front races in, catches up with the warm front, closes it, and it's done. But while those two fronts are closing, we get very, very uneven weather. We get lots and lots of different weather conditions. We'll talk about those afterwards. But the two together creates very particular weather conditions. And that's called an occlusion. When two fronts come together, they occlude. When they do that, that's where it begins to close up and the depression goes away again. And these things don't take very long overall. They only take about 1 to 5 days. And they're not particularly big either. They are around hundreds of kilometres in size. So they're quite quick, they're quite small, and they happen quite frequently. So let's think about the weather conditions that come with these depressions now. With our depression weather conditions, we have to think really in terms of one big system that's moving along. So it's going to be moving along in this direction. And we have to imagine that we're sort of stood at a point and that this thing moves across us. Because that's what we see. Because this is moving across the UK, we have to imagine that this whole block is moving across us. So what would we see? Well, as this thing first starts to move in, we pick up very high, wispy clouds, and these are called cirrus clouds. That's from the Latin, just means wispy. Cirrus clouds up here, and then they start to get thicker and thicker and thicker, and we start to get what are called cumulus clouds around here. Cumulus means lumpy heap. Again, this is genuine Latin. And when you get these clouds, you start to get more rain. So we get rain as the warm front comes in, because this is the cold air here. And the warm air is coming in. That is the warm front. It's the front of the warm air coming in. And then we get these called stratus clouds. And stratus clouds are from the Latin layer. It's just a thick, low cloud. This is in the warm sector. It might not actually feel very warm because the clouds are blocking out the sunlight. So temperature might not change too much. It might go up by a couple of degrees. But these are stratus clouds along here, and you get a bit of drizzle throughout that, prolonged and continued. So when you have a really flat grey day, that tends to be what it is. And then we get to the cold front coming in. Now the cold front is pushing in, it pushes in quite hard. This all occurs quite steadily, but then the cold front comes in quite quickly. And this is where we get nimbostratus clouds. And these are big anvil-shaped clouds. So if you ever watched old-fashioned cartoons where an anvil gets dropped on someone's head, that is the same sort of shape that these clouds are, and they're very dark. And they've got these masses of water vapour and water droplets inside them, so we get very, very heavy rain from these big clouds. And then when that passes over, get a few speckled clouds around, but it becomes bright again. So we go from bright to high clouds, low clouds, thick, low clouds, and then masses of rain, and we're back out the other side again. And all this time, this is all moving across. So if we imagine our relative position, we're sort of like that as we go past. It's actually the weather that's moving, but we're relatively moving like that. So because it's unstable air, we get a lot of wind, we get a lot of rain, we get a lot of snow. The wind because it's more moving, the rain because of the clouds, snow if it's winter. So that is the basics of a depression. We're going to cover that more in class. We're going to have a look at anticyclones next, which is the other type of atmospheric system. Thanks very much.